So we already see how TypeScript can help us during development. Now, we also know that there is a number type in JavaScript, and we can see it with the built-in type of operator. This is now not TypeScript specific. This is a built-in operator and keyword supported by JavaScript. We can use it to get the type of a certain value. So here we could console log type of number1. And what we'll see if we do that is that as soon as we compile this so that we run the updated code, here we print number to the console. Now we do that thanks to this output here and thanks to the type of operator. And in vanilla JavaScript without TypeScript, we could use that to also improve our function here. We could check if type of number is equal to number, type of n1 I mean, if that is equal to number, and we could also check if type of n2 is equal to number and only perform our operation here if it is, and otherwise throw an error. Or do the opposite and check if it's not equal or if n2 is not equal. And if either of the two is not a number, then we could throw a new error where we say incorrect input. This actually would be a non-TypeScript way of ensuring that we can't call this function with a string here. If I do this now and I recompile, we get our TypeScript error, but let's ignore that for now. If we rerun this, we get the incorrect input which we're throwing ourselves. So now we hardened this function in JavaScript. It fails at runtime, but failing might here be better than showing an incorrect output which we had before. So this would be a way of checking the inputs in just JavaScript. You don't need TypeScript for that. That's regular JavaScript code. But of course, this approach has downsides. Sometimes it's the right thing to do. Sometimes you only can validate certain inputs at runtime. But the downside is here, we're checking something which we actually can avoid during development with TypeScript. So yes, we're throwing an error, and in our application, we might have built-in measures that can then fall back to some other behavior to save the running application. But still, we're throwing an error which is really not necessary to occur in the first place. We could have prevented it with TypeScript. And here we really see the difference between JavaScript and TypeScript when it comes to types. JavaScript is dynamically typed, which means it's perfectly fine that we have a variable which initially might hold a number where we later assign a string to it. And that's why we have the type of operator so that we can check the current type of something at runtime if we have some code that depends on a certain type. TypeScript, on the other hand, is statically typed, which means we define the types of variables and parameters and so on during development. They don't suddenly change during runtime. Now, of course, since TypeScript is compiled to JavaScript, they theoretically could, but if we use TypeScript and we write code where we suddenly assign a new type of data into a variable, where we previously set that this should be a number, for example, and now we're assigning a string, then we get an error during development so that we are forced to be clear regarding the types something can or cannot hold. That's the difference here. So we don't really want to use implementations or solutions like that if we can avoid it with TypeScript. Still, it's important to know that JavaScript, of course, knows about the concept of types. It knows about some types like number, string, and boolean. But using that always means that we can only fail at runtime instead of during development, which is a better place for us as a developer. It allows us to fix bugs earlier. And in addition, JavaScript only knows about a couple of types. As you will learn throughout this course, TypeScript knows about way more types than JavaScript. So this runtime checking is really not as flexible or not as powerful as what we can do with TypeScript. And for all these reasons, this approach is actually not the approach we want to use here. Sometimes it can be useful to get the type at runtime, but sometimes, like in this example, it's way better to get it during development. The only important thing to recognize, of course, just is that with TypeScript, you only get the support during development, not at runtime, because these TypeScript features and checks are not built into the JavaScript engine, so that logic can't execute in the browser. It can only execute during development when you compile your code.